All right, let's try this again. The first one is a prerequisite, so you won't have to do this too much. This one is talking about multiplying two monomials right here. You add the exponent. So you do 2 times 3 is 6. My x's, I have 2 x's over here, and I have 1 more over here. When you multiply exponent or bases that are the same, you add the exponent. So I have 3 x's. And then my y's, I got 1 right here and 3 more over here, so I have 4, okay? So this is just a prerequisite topic that you need to know how to do, an exponent rule. We'll probably do some more exponent rules later on in the class, but that shouldn't be too bad. All right, what the main chunk of today is about is systems of linear equations. There are 3 ways to solve system of linear equations. We'll probably only do 2 in here because you might have seen one of them, and one of them doesn't work great by doing a ham. So it's graphing, substitution, and the addition or elimination method. So when you graph these, what you're looking for is the system of equations. I'll kind of show you the 3 options here that they talk about. Okay, so lines have 3 options when you graph 2 lines on a Cartesian coordinate. So you have 3 options. You can intersect, okay? They have an intersection point. This is what we are trying to find in a systems of equations, is we are trying to find what point lands on both lines, okay? So it is actually the intersection point. The intersection point is the only point that lands on both lines. So you could graph like supply and demand and see when they meet, or you could graph like profit and cost and see when they meet. You could graph a bunch of different things and kind of see when they meet. So the intersection point of these is what we are looking for. So every time we solve a problem, I kind of think about that. Okay, that's where those 2 points meet, because that is the one point that is on both of those lines. The other 2 options, which we don't really talk about, are parallel lines. Parallel lines never touch, okay? Okay, so this would be like a no solution type problem when we are looking for the intersection, because they never touch. So there is no intersection. There is no point that is on both of those lines. And then the last one is the last way that we recognize things is if they meet at a 90-degree angle. They are called perpendicular. They meet at a 90-degree angle. You know what? There is one more, I guess, kind of. We don't ever deal with perpendicular here because all we're doing is looking for the intersection point, and the intersection point is that one point right there, so that one works. There is nothing weird there. The other weird one that we have here, anytime I mention parallel, I just think of perpendicular because they just go kind of hand in hand. But it doesn't really change what we're doing on here. The one other weird one that we do, parallel and perpendicular just go together, is if I have one line right on top of each other. That actually ends up being the same line. You Gator fans hate that color. Those colors mixed together. The same line. So they are actually the same line. So if we're looking where the intersection is, the points are for each of those, the same line, they actually end up being the same line, which means there is an infinite amount of solutions. Okay, because every point that's on the purple line is also on the gold line. All right. So really, perpendicular is just an intersection, but we are looking for the intersection point. So if they're parallel, we don't get an answer. So one of the ways to do this is to graph this and look for the intersection point, but it's really hard to do by hand because we don't draw perfectly, so you can't hardly tell where it is. When you graph with technology, it's very easy to tell, but we don't even have a graphing topic in this class because it is just hard to do by hand, and it's easier to use technology. So the algebra, there's 2 different algebra ways to do it. The first way is called substitution. So they will write these, and they look like this. The substitution method is easier to do when you have a variable that's already solved for. So like right here, I have y equals 2x plus 3. Most of y'all us prefer the other way to do these, but it is easier to do the substitution way when you already have a variable solved for. So like y is already by itself. So what I'm going to do is substitute that in to this y right here. So I'm going to rewrite the second equation, And instead of writing y, I'm going to write what y is equal to. Y is equal to 2x plus 3. Okay? So this is called the substitution method because I know what y equals. Y equals 2x plus 3, so I rewrite the other equation. And instead of writing y, I write 2x plus 3. Now I have an equation with all x's in it, and I can solve this pretty easily. Combine like terms. Subtract 3. Divide by 5. Okay. So that is my x value. So remember, I'm looking for an intersection point, so I need to find the y value. So anytime you get one answer, you always want to take it and plug it back in. Okay? You got to take it and plug it back in. So you can plug it back into the top or the bottom one. It does not matter. I'm going to plug it into the top one because it's already solved for y. So I plug a 2 in for my x, and I get y equals 7. So these intersect at the point 2, 7. Okay, these intersect at the point 2, 7. I believe Alex does a very good job of not giving you fractions on these. So if you get a fraction, you probably missed a sign or something like that. But you can let me know if I'm wrong. Okay, so that's the substitution method. We'll do one more just because. Again, I usually only like to teach one method of doing things because I don't want to have multiple methods of doing things for you because it gets confusing. But in this scenario, it is easier to use substitution only if the variable is already solved for. So this one, the x is already solved for. So I know x equals 4y minus 1, so I can take it and plug it into that x right there. So instead of writing x, I write what x is equal to, 4y minus 1. And now I have an equation with just y's in it, and I can solve that. So in this one, I need to distribute. So I get 8y minus 2 minus 3y equals 5. Combine some like terms. So that's 5y minus 2 equals 5. It's going to give me a fraction. No. Well, Alex is good about not giving you fractions, but ChatGPT apparently is not. Can we change this to 3? Will that terribly upset you? It's better than having a fraction. Change that last number to 3 right there, and then we won't get a fraction. So add 2, and we get y equals 1. All right, and again, once you get one answer, take that and plug it in to find the other one. So x equals 4 times 1 minus 1. It does not matter if you plug it into the top or bottom. On the substitution one, it's always easier to plug it into the one that's solved for. But x equals 3. So these intersect at the point 3, 1. All right, so the substitution method is easier when you have a variable already solved for. But honestly, most scenarios, you do not have a variable already solved for. They are in standard form, and they look something like this. 2x plus 3y equals 12. 4x minus 5y equals negative 2. Let me try to do it in my head real quick to make sure I don't get... I think we're going to get a fraction again. Man, Grok is struggling on this one. Let's change 12 to 10. Sorry, it's better than having fractions, though. Should have double-checked some of these. Okay, So this is the form that most of these come in. What we're going to do is we want to be able to add these up. So they call this the elimination or the addition method. We want to be able to add these up so that a variable cancels out. Well, if I just add these up right now, I'd get 6x minus 2y equals 8. So nothing cancels out. But what if we manipulate the equations so that something cancels out? So what's easy to do here is the x's. I know this is positive 4x. Well, what if I made this be negative 4x? I can make 4x and negative 4x cancel out. So to go from 2 to negative 4, I would multiply by negative 2. So I'm going to take negative 2 times the entire top equation. If I take it negative 2 times the entire top equation, it does not change my equation because I'm multiplying everything by negative 2. So negative 2 times 2x is negative 4x. Negative 2 times 3y would be negative 6y. And negative 2 times 10 is negative 20. All right, so now when I add these up, by the way, when you multiply this, make sure you multiply that one by, that's a common mistake. You got to multiply the entire equation by negative 2. When I add these up now, 4x plus negative 4x cancel out. Negative 5y plus negative 6y is negative 11y. Negative 2 minus 20 would be negative 22. So my x's are eliminated. That's why they call the elimination or the addition method. You add them up to eliminate a variable. And now I have a very easy y, a formula with y in it. I just divide by negative 11, and y is equal to 2. Okay, and just like before, once you get one answer, take it and plug it in. You can plug it back into any one that you want to. Like I'm going to plug it back into the top one. I don't really have a reason for that. There's no negatives in it, so I guess that's good. So 2x plus 6 equals 10. 2x equals 4. X equals 2. Sorry. So on this one, we want to manipulate the equation so that when we add them up, they get eliminated. And then once you get one answer, you plug it in. Oops. Don't tell me it kicked me out of Alex. I haven't been talking that long. It did. No. Now I went to the wrong class. They kicked me out of everything. Actually, let's go. Sorry, I was going to pull one from Alex, so we definitely didn't get fractions here. This is a different class, but it's got that topic in here. All right, let's find. There's one I was looking for. No, I don't want to do that one. Yes, negative 3x minus 4y equals 9. (5x plus 9y equal negative 15). Negative 15? Yes. All right. So when I look at this one, I need to pick a variable to cancel out, to eliminate. It does not matter if you pick the x's or the y's to eliminate. You can eliminate either one, but you may have to multiply both equations. So which one do y'all want to eliminate? Probably the x's, right? Because 3 times 5 is 15, but 4 and 9 is like 36. So you're going to get bigger numbers to work with if you do the y's, but that's fine. So what I need to do is make this one, I'm going to make this one be negative 15x and the bottom one be 15x, positive 15x. I'm making the top one be negative because it's already negative. So that's what my goal is. So to do this, I'm going to multiply this one by 5, right? 5 times negative 3x is negative 15x. 5 times negative 4y would be negative 20y. 5 times 9 would be 45. And then my other one, I need that to be positive 15x, so I multiply it by 3. 3 times 5x is 15x. 3 times 3 times 9 is 27. 3 times negative 45, or I'm sorry, I keep saying the answer. Negative 15 would be negative 45. All right. So when I add these up, my x's cancel out. I get 7y equals 0. 0 is a number. That is fine. That does not mean anything weird happens. So it's my y here is 0. That is okay. And then once I get one answer, I'm going to plug it in. I'm going to plug it into the bottom one. I don't really know why, just because. So 9 times 0 goes away, so I have 5x equals negative 15, and x equals negative 3. So these intersect at the point negative 3, 0. So you may have to multiply both equations to get a common number to cancel out. You just want to kind of find the least common factor there, or not factor, least common multiple, to do these. I'm sure we'll do another one on this word problem. Let me see if they have. Man, why did it log me into my other? Come on, Face ID. I'm going to go pull a word problem to make sure we do the same word problem that y'all have instead of something different. Okay, system of equations. We want solving. You only have 5 topics in this one? Okay, they are a little bit longer problems, so. Let's do this word problem instead of the one Grok came up with. All right, Miguel, the trainer, has solo workout plans that he offers his clients. Plan A and Plan B. Each client does either one or the other, but not both. On Wednesday, there were 9 clients who paid to Plan A and 7 who did Plan B. On Thursday, 3 to A, 5 to B. Miguel trained his Wednesday clients for a total of 12 hours and his Thursday clients for a total of 6 hours. When you do these problems, I think it is easier to kind of make a chart. So Wednesday, Thursday, we have a total of 12 hours and 6 hours. And then we have Plan A and B. Okay. So A was 9 on Wednesday, and B was 7 on Wednesday. On Thursday, it was 3 and 5. This kind of shows you how to set up the equations, okay? So now I have 9 for Plan A. I got to figure out how long to make Plan A, so that's my X. So 9 clients times 10 minutes each would be 90 minutes. Plus 7 times Y would be 12 because we have 12 total hours. And then same setup for the other one for Thursday. 6 total hours. You got 3 on Plan B. You got 3 on Plan A, 5 on Plan B. Once you get the equation set up, that's to me is the hard part. That's why I'm saying make a little chart right there to try to help you out because then it kind of translates straight down. Whatever is, how do I say this? that last sentence there, second to last sentence where it says Miguel trained his Wednesday clients for a total of 12 hours, that's going to be like one equation. Where it says the total amount, that's going to be my Wednesday. So Wednesday is going to be one equation and Thursday is going to be one equation. So when it kind of look down there towards the end to help you do this, because if you try to make one equation be plan A and one equation be plan B, it doesn't work out quite right because that total, what do we do with the total? Because it's A plus B would be my total. So you always want to look at that like second to last equation and figure out my total amount, like what I'm dealing with, and that'll tell you what my equation is. So Wednesday is my first equation, Thursday is my second equation, and then you can do your columns, the A and the B. All right, so to solve this, now we're going to do just like we were doing. I'm going to, looks like my x's would be pretty easy to cancel out. I could just multiply this by -3, and that would give me -9x, right? -3 times 3x would be -9x. -3 times 5y would be -15y. -3 times 18 would, I'm sorry, I keep saying that. -3 times 6 would be -18. And now add these up. 9x and -9x cancel out. I'm not looking at this one really, right? Because I'm adding the bottom and the top up. 7 minus 15y would be -8y. And 12 minus 18, I'm going to get a fraction. Ooh, they did this. Alex did give me a fraction on the word problem. I guess it kind of makes sense to have a fraction on a word problem because we're talking about time here. -8y equals -6y, divide by -8. And they put it as a decimal. If you want to, you can do 3/4, but they put it as a decimal because all we got to do from here is plug it in. We're talking about hours, so like y is going to be 3/4 of an hour. So now let's take that. Once you get one answer and plug it in. I'm going to plug it into that one I crossed out. 3x plus 5 times 0.75 equals 6. So that's 3x plus, what is that? 3.5? Math is hard on Monday at 8 a.m. 3.75. All right, minus, subtract that over. So 3x equals 2.25, divide by 3, and x equals 0.75. So I know we don't want decimals and fractions and things like that. This is our intersection point. But what we're really saying is for plan A, we want it to be 3/4 of an hour, and plan B, we want it to be 3/4 of an hour. So we want it to be, each of them to be 45 minutes, and then we can fit all of our clients in. Most of the ones I think should have that same pattern of setting up. And the hard part on this is to set those up. All right, last topic. I'm scared I should pull this one from Alex too because this one can get very hard. Although we should know how to solve everything. Y equals x squared plus 6x. Negative x plus y equals 24. All right, so what happens if we are solving a nonlinear one with like an x squared? You have an x squared here. The only way to really do this one is substitution. You can't do the addition method unless they all have the same, which is not going to happen on these. So we have to do substitution. So we have y equals this. So we are going to plug this into the y. So I have negative x plus x squared plus 6x equals 24. Should be good. Refresh over some of the stuff we did last week. But I am taking that and plugging it in to the y. Right? Y is equal to x squared plus 6x. So now combine like terms. I have x squared plus 5x I'm going to go ahead and subtract the 24 over. I know that's 2 steps at once, but I think y'all can probably handle that. Because this has an x squared and an x in it, so I need to go through my factoring steps. So my factoring steps, what multiplies to be negative 24 and adds up to be 5? Be what? Positive 8, negative 3. So x times x is x squared plus 8 minus 3. So now solve both of these by setting them equal to 0. So x equals negative 8 and x equals positive 3. I'd say this, what's coming up is the most annoying part of these problems. I've said it a bunch, but once you get one answer, you have to plug it in. So I have to go plug in both of these. So to plug in x equals negative 8, I'm going to plug it into the top one. Negative 8 squared plus 6 times negative 8 would be 64 minus 48 would be 16. And then plug in a 3. Would be 9 plus 27 would be 36. So I have 2 intersection points here. Because I got 2 different answers. Now, real quick. One of these is a line, right? And one of these is a parabola because it was x squared. So if I graph this isn't what they look like, but if I graph a quick picture, you can see that there is a chance of 2 intersection points. So there are 2 intersection points on this one because if you have a parabola and you have a line and they intersect, there's a good chance that they intersect in 2 different spots. So if it has x squared in it, you are going to have to do the substitution on this topic. But if you get 2 answers, you have to plug in both of them. But not really anything changes from there.